Let's talk about the notation we use to talk about domain and range and other pieces of describing functions. So there are three different kinds that we're going to talk about. One of them is my favorite kind. Hint, it's this one right here. But I will show you all three because you could come across all three at any time. The first is inequality notation. So if you are looking at this diagram here and we want to describe what x values are being represented, you're going to say, well, it's all the x's that are greater than -1 and less than 2. Now, note that this is a closed dot right here, a closed point. So this point means that we're also going to be equal to -1. And that's inequality notation. This open circle means that you will not be equal to 2, just to refresh your memory there. So this inequality notation we've used since Algebra 1, and that is common and comes up a lot. Okay, let's translate that into interval notation now. Interval notation gives you the same information, just in a little more of a concise way. So you still go from left to right. I'm starting at -1 and I'm ending at 2. I'm putting a comma in between. If I have a closed circle, closed point right here, then I'm going to say I'm going to include -1 by using a square bracket. And this means that the interval is closed or inclusive of that endpoint, inclusive of -1. And then at 2, I'm going to have an open parenthesis, which means it is open and it does not include 2. Okay, so this and this mean the same thing. They're just two different ways of writing it. Set notation is a little less common, but it does come up. So set notation looks like this. When I have set, I just call it fancy inequality. I define the set that I'm pulling from. Sometimes you'll just see an x, so you're talking about the set of all x's. Sometimes you can be a little more specific and talk about the set of all x's in the real numbers, okay? Such that, this vertical line here means such that, and it means that I'm going to define a condition, okay? So I'm talking about all x's in the real numbers such that x is greater than or equal to -1 and less than 2. And then I close my set with braces. Okay, so this is set notation. It's just a little more formal than inequality notation because it is giving you this the set that you're pulling from. So just be able to recognize it, be able to use it if you need to. But again, my most favorite one of these is interval notation, and I will use that more often than any other one. Okay, let's look again. Here's another set of numbers and I want to be able to express it. I'm going to express it first in inequality notation. I'm going to say I'm talking about the set of all x's that are greater than -3 and less than or equal to 2. This, because this is a closed point right here, and this because this is an open point right here. Okay, interval notation for this starts and ends at the same spot. So I'm going from -3 to 2, but I have an open parenthesis where I have an open point and a closed parenthesis where I am including my endpoint. So open parenthesis means I am not including my endpoint, closed parenthesis means I am including my endpoint. Okay? Set notation for this is the set of all x's. I'm going to go ahead and say in the real numbers just so you can see that because I think it's nice. Where x is between -3, oh, not inclusive, it doesn't include -3. So where x is greater than -3 and less than or equal to 2. And the way we talk about that, we say that this is strictly greater than, which is the way of saying not greater than or equal to. Okay, so this next interval has an infinite component. So what we're going to do is describe it in our three different notations. In inequality notation, you would say that this is all the x's that are less than or equal to 2. okay? And some people might be tempted in some books or some places to say that x is also greater than negative infinity. And while that's not wrong, it's just a lot of extra information, and extra information tends to be frowned upon, right? We have all we need to know when we say that x is less than or equal to 2. So it is better notation. It is better to write less if you can, all right? X is less than or equal to 2 describes this plenty. So leave infinities out of inequality notation. But we do want them in interval notation because I need a left. If I'm going to write an interval, I need a place to start. And the only place to start here is negative infinity, okay? And I'm ending at 2. So I'm going from negative infinity to 2. I know that this is closed. I'm including 2. We say that infinities are always open. We are never going to include a negative infinity because I'm never going to reach negative infinity. It's not a number, it's an idea, right? You can't touch it. So infinities are always open. The set notation for this is the set of all x's in the real numbers, there we go, where x is less than or equal to 2. Okay. Now we can write domain and range in inequality, interval, and set notation also. So if I'm looking at the domain for this, and I want to write it in inequality notation, I'm going to say, well, it goes from left to right. Okay, it starts at -1, so it's from -1, and x is greater than -1, and then it's going to go to infinity. And in inequality notation, I don't want to write the infinity. So you could write -1 is less than x. More commonly, we would say x is greater than, but not equal to, -1. It is strictly greater than -1. And that's our domain in inequality notation. In interval notation, this is going from -1, open, because we're not including that -1, to infinity, also open, because infinities are always open. And then in set notation, we're going to say it's the set of all x's. I'm going to shortcut it. Sometimes we put in reals, sometimes we don't, where x is greater than -1. All right, now I forgot about the range, so I'm going to squish that in over here. Don't mind me. The range for inequality, or in inequality notation, goes from negative infinity all the way up whoop, to 2. So the way we say that is we say that y is less than or equal to 2. Okay, all the y's less than or equal to 2. In interval notation, we say that that goes from, it starts, right? We're going from bottom to top in interval notation. So we're starting at the bottom and going until the top. So I am starting at negative infinity down here. So I'm going from negative infinity up to 2. And 2 is included. And if I'm touching this point 2 right here, you can always assume it's included unless you see an open circle. Okay? And then the set notation for the range, remember that range is talking about y's. So we're going to say it's the set of all y's, all right, where y is less than or equal to 2.